The trouble with powder is that it blows away in the wind. To ship powder hundreds or thousands of miles to market, specially designed trucks and rail cars are needed to protect it. One of Wyoming's prized mineral industries produces soda ash. When it's ready for market, it's delivered as a powder. Tons of powder. A specialized system transfers soda ash from trucks to railroad hopper cars. This system is located at Bonneville Junction in central Wyoming. There are 5 silos here, one for each soda ash producer. Incoming soda ash isn't mixed together because each producer has its own customers, and everyone's soda ash is a little bit different. So this system keeps everything separate. It's brought in on separate trucks, delivered to separate silos, and loaded onto separate rail cars. That's not all. Plant operators have to keep up with soda ash supply and demand. Their job is to have enough, not too much, not too little, on hand in each silo. This is a real-world math problem. Let's see how this business operates.
Today's problems involve geometry, the ability to calculate volumes and capacities of 3-dimensional shapes. How much soda ash can one of these silos hold? Can you fill the silo to the brim? How do you know if there's enough soda ash inside to fill a rail car? When do you know you need more soda ash in the silo? Every hour, 4 trucks deliver soda ash to the Bonneville facility. These trucks, with their double trailer configuration, carry between 44 and 52 tons of soda ash. The system is designed so that any one of the 5 silos can be filled with soda ash as the truck unloads.
And the belt is running at about roughly a 300 ton per hour rate. And from there it goes directly up the incline. And if it needs to go in one of the other 4 silos, the drag chain will be on and it'll carry it across the drag chain and into the silo that it's intended for. And that's kind of the beauty of the system, is its simplicity. To the very top, the silos are right at 80 foot.
Top of the silo?
The top flat part of the silo that you can see from here is about 80 foot.
Next to the silos is a rail yard filled with hopper cars. Some have already been loaded, ready to be added to a freight train scheduled for later today. Others are lined up to be loaded.
And the little bunch that's sitting all the way up there on the east end of the other track up there,
right,
they're Kansas Cities, they'll be going east.
Oh yeah, they go out tonight, huh?
They'll go out tonight.
The bottom of each silo is shaped like a funnel. The loading operator selects the silo that feeds the conveyor belt. Then the conveyor belt system shuttles soda ash to a hopper above the loading dock.
Each car we scale it out and we load it. They can't be over 263,000 pounds. On the average, if we figure out all the cars that we load in a year and we divide that by the tons, we average 98 ton per car.
As cars are pulled past, dust guards keep soda ash from blowing away. Finally, the cars are weighed and picked up by a locomotive. Where does the soda ash go? Who uses it?
We send to Ash, Michigan and Floref, Michigan. We send to Castlehane, North Carolina. We send soda ash into Canada. And the large majority of what we send soda ash to goes for glass production. We send to Castlehane, which is the world's largest manufacturer of fiber optics. We send them 3 cars a day.
When everything is done correctly, soda ash remains in these silos for just a few hours. And it takes math to figure out how much you've loaded and how much you can add. Let's try to work some of the math problems this company faces in the real world.